504 is the number. You can see it from here. Instead of talking about that, we're going to be talking about, we did a lot of research in the area of the Tor network. That's where we specifically focus. We work an awful lot with regional organised crime units. We've also done a lot of research into different types of denial of service attack. And while we did our research last year, we found a few more interesting things. A few of the attacks that we found, we broke down the anatomy in our labs and we replicated the attacks. We found them to be thoroughly interesting for the specific reason that they avoid or specifically evade modern security operations center technologies. And whether it's deliberate or not is debatable, but we found it interesting, so I thought I'd share some of that data with everybody today. Okay, PowerPoint. Excellent. Okay, so first I want to talk about, for those people who don't know Security Operations Center, the expectation versus the reality, which tends to be an interesting conversation. I'm going to fly through these because this is actually a half-hour presentation and I think I've got 20 minutes. So if I talk really fast, excuse me. If you have any questions, come find me afterwards. I'll happily explain. So if we look at the expectation versus reality of a Security Operations Center, people tend to think it's this dark room full of banks of monitors that have, finite vision into every area of the network, and as soon as somebody crosses a perimeter, I don't know where you get a perimeter alarm from, but all the screens start flashing red, and there's an army of cyber ninjas that jump into water with their green screens and start protecting the network. The reality tends to be a little bit different. Yes, there is a bank of monitors on the wall. It's not because you need it there, it's not because that's one system that displays everything, like a single screen is split over multiple monitors. It's because you need multiple monitors. It's multiple systems that are monitoring everything. And there does tend to be an awful lot of gaps between those systems, and in order to get the data from those different systems and actually make sense of it, you require the security professionals. That is the key that holds these SOCs together. It's the guys who know to take the data from your configuration auditing system, the data from your SIM system, the data from your asset monitoring platform, and correlate that data all together to see, actually this is an issue, this is something that's actually happening. But I don't want to ruin anybody's illusion. There still is this team of cyber ninjas that jump into action with their green screens and protect the whole network. So, SOC technology. As I mentioned, there isn't like a single, far from what people believe, there isn't like a single technology where you say, show me my network, and it shows you everything. You have multiple systems, and putting those multiple systems together and gluing them together is the key. Everything from SIM, log management, which tends to be this kind of staple. Everybody has that in their SOC, which pulls together all the logs from the different systems into a central location, allows you to run correlation rules, allows you to run forensic searches and analyze all of that data. But there's also configuration auditing. The reason why you need this, we may actually cover this in a slide's time, but I'm going to do it now because it's more fun. Why would you need log and configuration auditing? Well, if you get a log that says Jonathan Davis made a configuration change on my core firewall at 10:04 from this workstation, that's fantastic. That is the point of SIM. Out of the 10,000 logs that I received that minute, I received one log that told me that Jonathan Davis made a configuration change. SIM's not useless. SIM's enormously useful. But what was the change that Jonathan made? That's not in the log. You have no idea. My firewall log in my firewall in my office, the configuration file is 1,300 lines long. If Jonathan changed an IP address from 192.168.1 to 192.168.11, how the hell am I supposed to find that manually? And this is what I'm saying, configuration auditing software is extremely useful. Tripwire downstairs, great software, does configuration auditing. I'm not pitching for them, but they're a good software. Having a SIM in place and having a configuration auditing system in place, the reason why it's essential that you have both is so that you can see who made a configuration change when, but you can also see what that change was. And what happens if you want to know what the effect of that change was? Did it introduce any new vulnerabilities onto my network? Did it introduce any performance problems? Did it speed my network up? You never know, it could happen. All of these different things are different systems, and they're run by different people in the organization, and actually run by different teams. Performance and asset management systems are usually run by the NOC. Log management and configuration auditing systems are usually run by the SOC. So actually having all of these different systems in the organization is the problem. Oh, and I said there was going to be a slide that somebody did this. It's the exact thing that we just talked about. We say, look, somebody makes a configuration change on the network, on a gateway firewall, the log event says, here's somebody's done that, but it doesn't actually say what the change was. You need to go and get that from a different system. It doesn't say what the effects of that change were. That's a whole ton of different systems. So this is basically a slide to graphically illustrate what I just said a second ago. Okay, so now that we've talked about what a SOC is, I wanted to get that out of the way because it kind of is the theme for what we're about to view. Let's look at 2 use cases because it's all we've got time for in a 20-minute presentation. Let's look at 2 use cases that explain how attacks are modifying, or how attackers are modifying their attacks to specifically evade these technologies. There is an attack called Dark Reaper. This attack is a form of denial of service. For those people that don't know, if you don't know, you probably watched the whole presentation, but for those people that don't know, let me give you a quick summary. What is DDoS? So, denial of service is basically making a service unavailable by spamming the box with illegitimate traffic. So, the box doesn't respond to legitimate users. Distributed denial of service is where instead of having one person spam a box with 100 meg of traffic, you have 100 people spam the box with 1 meg of traffic. It's the same thing, it just has multiple sources. It is a little bit harder to detect, but nowadays with all of these technologies that you got downstairs, it's pretty easy to do. There's some more information. These are what we call layer 4 distributed denial of service attacks, because what they're actually doing is instead of, they're actually attacking the box by sending it a whole flood of traffic. That traffic, it doesn't really matter what it is. If you send 100 meg of traffic down a 2 meg internet connection, you're going to make that box unavailable. However, what we actually saw a little bit later, there was a chap called The Jester. If anybody doesn't know who he is, go and read about him. Time magazine actually named him as one of the 30 most influential people in internet history. This is a hacker. He was on the same list as the guy that invented Yahoo and Hotmail and Google and all the rest of it. So he basically changed the game a little bit. Rather than these anonymous kids that were getting tens of thousands of kids in their basements to go and attack Visa and PayPal and MasterCard because they refused to take donations for WikiLeaks, he took down WikiLeaks by himself from a single laptop. Now, the power of Anonymous, the power of what they were doing, was that they had 10,000 kids and they were, sending this spam software. If you don't know what it was a low orbit ion cannon, and there's a whole bunch of other ones, a high orbit ion cannon. They essentially just flood traffic, and all they have to do is tell these kids, put this IP address in and set the rate of traffic to 2,000 and go. And it's really not a big deal, but it did lead to tens of thousands of kids thinking that they were hackers, which was funny. This guy created an attack that rather than attacking the box, he was attacking the application that sits on that box. So when you send a request to a server on port 80, it's not the box generically that responds, it's an application that's running on that web server application, whether it's Apache, IIS, etc. And he actually found exploits that allowed him to attack that application. What it meant was he didn't need to send 100 meg of traffic or 100 gig of traffic to go attack the box. He'd spend 700 kilobytes per second of traffic. He actually managed later on in some of his attacks to bring down entire corporate web servers and things like Westboro Baptist Church from an Android mobile phone that he reportedly sellotaped to the bottom of a table on an internet cafe and left running. This new form of attack was very, very, very dangerous, very, very, very effective, and look, it spawned an entire industry to try and protect against it. So that's a bit of a history of what DDoS is. Here's a bit of a history on, for those that don't know, what the Tor network is. The Tor network, Tor stands for the Onion Router. It was created by the US Naval Research Laboratory as a means of anonymous communication for US intelligence services. It was created with very good intentions, and it is still used with very good intentions by people like The Guardian, unveiling all sorts of stuff. People in dissident countries, Syria, China, Iran, that have been able to go around their Great Wall, Great Firewalls to get information out. It was used extensively throughout the Arab Spring for people to be able to communicate on Twitter and Facebook and all things, but they use Twitter and Facebook through the Tor network because it provides anonymity. However, it has also been misused by many. I mean many. It's basically the new home of child pornography. There's all sorts of sales of guns and drugs and anything that you can think of that's pretty depraved, you'll find it there. And so it also tends to be immune to DDoS because of this layer upon layer of routing and encryption that the Tor network uses to make the users anonymous. It tends to be a bit slow, so you can't send 10 gig of traffic down the Tor network to one server, not without burning the Tor network itself down in the process. So nobody really was attacking the sites that were on it, but of course there was more and more of these depraved sites popping up, until we saw a guy called Tor Reaper. Tor Reaper showed up 18 months ago and basically started attacking child pornography sites on the Tor network. That was his thing. That's the reason for his name, I guess. And he started being able to bring them down. This actually caught our attention because not many people could bring down Tor sites, and he was taking down marketplaces, not Silk Road, but other competing marketplaces, similar kind of things, and he was taking down child pornography sites constantly. So we started to try and look at his attacks, how he was achieving it, and what they were doing. I'm going to have to whiz through an awful lot of this because of the time constriction. I've got kind of one eye on the clock. So the attacks that he was generating, we recognised that they had sort of all the hallmarks of the ones that the Jester was using. We did also notice though that it was working on different types of web server, which was unusual. Ordinarily, layer 7 attacks were targeting, you'd have one attack and it would target one specific application. So you'd create an attack that targeted Apache, or you create an attack that targeted IIS. His one seemed to work on all different types of web server, which was kind of unusual. And of course, it was working through the Tor network. In addition to being able to attack things on the Tor network, he was able to route his attack through the Tor network to attack things on the plain internet. Super interesting stuff. And so that's the reason why we started to look into it. When we actually got his attack, and we started to look more closely at how some of this would have been possible, we were able to successfully reverse engineer his attack in our laboratory, and we found out that it wasn't exploiting a vulnerability in the web server software, it was actually exploiting a vulnerability in the HTTP protocol itself. So it was affecting anything that was able to use HTTP or HTTPS, irrespective of what the application was on the other end. We put some of the source code here. Don't worry, there's nothing here that's actually going to allow you to attack anything. But if you'd like to discuss how the anatomy of the attack in more detail, come and find me. We haven't got time to do it on this setting, but I'm happy to discuss it with anybody. But as we were able to replicate the attack, we started attacking all of our own servers for fun. And we started knocking these boxes offline. And we noticed something extremely interesting. Other than the fact that we could do it with a Raspberry Pi, that was really interesting. We were able to bring down an entire corporate web server with a Raspberry Pi, which is pretty cool. And then when you stack them and you start putting them in banks, it gets really fun because then you can knock down entire clusters with a cluster of Raspberry Pis. But one of the things that we did notice that was extremely interesting, so a layer 7 attack basically floods the application. So if you've got an Apache web server installed, by default, it's able to launch 256 concurrent processes. So if you've got an attack that can chew up one of those processes, and then you run multiple concurrent attacks, it should see the number of concurrent processes in Apache going up and up and up and up and up. If you get that number above 256, it's no longer able to respond to a genuine client request. So that's the way that the attack works. So we were able to attack our own web servers from a Raspberry Pi, run up 257 processes, which meant that the box no longer responded to our pings, to our web requests. But the box did respond to pings, so all of our monitoring systems were saying, hey, this system's fine, you've got no problems whatsoever, don't worry, guy. But in the whole time that we ran this attack, there was not a single access log produced. There is, interestingly, if you run the attack over a longer period, like 2 minutes, and you actually make genuine web requests, those web requests get logged to the access log. So even if you've got a SIM that's judging the availability of the box, it seems like everything's fine because genuine requests are still going into the access log. But not only was not a single access log produced by the attack, but not a single error log was produced by the attack. This was super, super interesting. And the reason why it's interesting comes back to how we started this presentation. Every major government, huge organization in our society today that's building these big SOCs, they use their SIM product to tell them when something's happening. If you go back to the example that I gave, I didn't even start my investigation process. And this is the thing, these guys are creating attacks that are specifically designed to evade SOC services, and the easiest way to evade it is to just not produce any logs. So this is an example of an attack that doesn't produce any logs, and we say, well, it's okay, right? Because they're using it to attack child pornography sites and ISIS sites and all of these different things. There's some examples up on the screen. But what happens when it gets into the hands of somebody that's really, really bad? Actually, sorry, just before we do that, there's a quick example. So I don't know if anybody knows UK2, they're a hosting provider here in the UK. Hosts tens of thousands of websites. One of the websites that they were hosting was reported to be an ISIS supporting website that was taking donations for ISIS. And so these guys, these anonymous guys, reported it to UK2, and because they didn't take the site down in 20 minutes or whatever time limit they gave them, they said, well, these guys are not being cooperative, guess we'll have to take the site down ourselves. But they didn't take down well, they did take down the supposedly ISIS site. They took down UK2.net. This company doesn't have a phone number. They do all their business through their website. They support tens of thousands of websites, and their only job in life is to keep websites online. These guys took down their site as well as one of their customer sites for 6 hours. It's a huge big deal. This is somebody who effectively is an innocent caught in the crossfire. But then, a few months later, we saw that the attack had migrated its way to somebody that really is bad. There was a group called Vikingdom 2015 who posted a SoundCloud notice to warn the United States government. So because of the atrocities that you're committing against black people in Ferguson, we're going to bring down all of your .gov websites. And they did. 39 of the 50 .gov websites in the US, including NYC.gov, Maine.gov, and these aren't brochure websites that says come to New York. This is where people pay their parking tickets, it's where people get their parking permits and things like that. These are active sites that people need to use. They brought Maine.gov down for 90 days. Even though halfway through that, Maine.gov switched to use a CDN service, Cloudflare. This attack reportedly goes through Cloudflare, as you can see. There's lots of other people that are using it, and if you collect all of the tweets and you follow them, you can see we've attacked this site even though it's through Cloudflare, we've attacked this site even though it's through Cloudflare. The other example that I wanted to go through today, and unfortunately I don't have time to dwell more on that one, which was cool, but there is another one which is using WMI to gain persistence on a machine, and to do so without any logs. So this research was done by a company downstairs, Mandy and FireEye. Great research that they've done. If you take a look at, firstly, what is WMI? I think based on the time, I'm not going to have time to go into this. It's basically a feature of the Windows operating system that allows you to access information and run mandatory, basic tasks like restarting services and things like that. There's various tools that allow you to play with it. I encourage you to go and find some. There's even tools that allow you to play with it from Mac and Linux systems. They effectively have their own query language called WQL, and it allows you to go and get CPU usage, memory usage, disk space, but it also allows you to track the current processes that are running and start new processes. The way that it does those is by having Microsoft have a default namespace that they allow you to query to go and get any information about the operating system. But what people don't realize is that it also, as a feature, allows you to create your own namespaces and put whatever the hell you want there. And it allows you to do this remotely, which is all sorts of fun. So the first use of WMI in an attack was actually Stuxnet. People don't realize that this attack on SCADA systems, which everybody knows was probably caused by a USB key fob that got plugged in and it created MOF files, and when the system restarted, those MOF files got executed, got put into the operating system's routines. What people don't realize is that it actually used WMI in order to, it used WMI to execute the code that was in those MOF files that then took advantage of a Microsoft printer spooler bug to go and do some damage. But if it weren't for WMI, that code never would have got executed. And this is actually the point. There's in 2014, there was a tool created called WMI Shell. WMI Shell allows you, as a security tester, let's call it, to create your own namespace in WMI. This is a database that's not part of the main SimV2 Microsoft database, which is where all the WMI data is. It allows you to create your own one. So I could go in and create a new namespace called John's Hacking Fun, and then I could create properties within that namespace that I could then store code can then be configured to execute based on events that happen. So we can use WMI to create a namespace. It can store the attack details, but it can also store the payload. So if I have a script, if I've got code which is scanning the machine to find credit card data, or it's scanning the machine to find passwords, or it's scanning the machine to find anything, I can take all the data that I found, and instead of uploading it to the internet or writing it to disk, which is things that all of you people have probably got technologies to discover, it actually writes it back to WMI and allows it to be remotely queried at the attacker's convenience. The best thing about all of this, none of this is logged. In Microsoft's infinite wisdom, no WMI actions are logged. So the creation of the namespace, not logged. The creation, when the code that was stored in the WMI property is executed, not logged. When the things that happen as a result of the code that's being run, because it was run by WMI, which runs as the system, not logged. So you can basically give yourself a backdoor into any system by creating a namespace, and this is the research that we did. We created a namespace, stored VB script code that created a user with administrator privileges, and then we created an event. So basically these can something called event consumers, and an event consumer is where you create an action for WMI that executes on an event. So in our case, we said every time the device reboots, create a user with administrator privileges called John's Hacker, and it creates it, and it can create it with no password, and it can just allow you to have access to anything. And because WMI runs the system, it doesn't log it. It's not that it doesn't log it, it does log it. It actually puts it into a special file. I'm going to hopefully get to that soon. There you go. There's this file within the Windows operating system called objects.data. Objects.data is an incredibly painful to read hex file. It looks like this, and the different parts of the hex data mean different things. It's incredibly difficult to read, but somebody did create a parser for it that allows you to read the data. It's created by Mandiant. It's called WMI Flare, I think. I have some information on another slide. Oh, here you go, solutions. So somebody did create something that allows you to read that, but even though they created that special tool, this won't be in any of your SIM products. This won't be in any of your log management systems. It won't be in any of your configuration auditing systems. This file, which contains all of the here's what WMI did, will not be in any of your security systems. And so that's kind of scary, and that's why I wanted to share the story with you today. I'm going to whiz through these because I think I've actually gone over my time limit, but here you go. It's called Flare WMI, which is created by Mandiant, by Mandiant FireEye. They have this tool that allows you to go read that file, and it will tell you all the things that have happened. I would encourage all of you to go do this today, because it actually contains historic information. So you could go analyze this WMI file on your systems, and you may find that 2 weeks ago something happened. I really hope that it doesn't, but I'm just saying it would be a useful exercise. And then start talking to your security vendors. Start seeing if they can please go and include this in their security collections. But the whole point of this presentation, the point of everything that I've said, is to say, look, if we can create attacks that don't create any logs, then we can negate the entire security process for most organizations. Because if I don't get the log that says something happened, I never go and investigate all the other things in the chain. And so what I'd also encourage is that people start to update their security process. Don't just have one primary indicator that tells you when there are security problems. Have multiple. And don't have this spotlight blinkered approach to monitoring of the network. If you can collect more than just log data, config data, using those as your primary indicators, and then having to jump in and out of multiple systems to go and investigate what happened, the whole point that we're trying to promote as a company is have all that data in one system. Have that complete visibility. When you get your alerts, have the alerts be generated not off the fact that a log got created, but the fact that the configuration change actually happened. So if you had an asset management system that was tracking your user accounts, which most of you will have for licensing purposes and in your NOC, if that was in your SOC and it saw that a new user account got created without a password, and it was called John's hacking user, you probably would have done something about it. But because it wasn't in your SOC, and because it didn't generate a log, none of your security professionals who are naturally paranoid ever bothered to investigate it. And so this is what the messages that we'd encourage you to go away with today. One, go find that file, look in it. Hopefully you don't find anything. And two, broaden what you use in your SOC to trigger the chain of events for your security professionals, who are the guys that wear the capes. You know, they are the superheroes that wear the capes. They do naturally find these things. But if they don't know to look, they'll never start. And so by you changing your process and creating the alerts of all the technologies, even stuff that you think belongs in the NOC, performance monitoring systems, availability monitoring systems, asset management systems, by creating security alerts of those systems, you'll be able to see more as it's happening and see these attacks that deliberately evade your processes. Or buy our software and it does loads of cool things. Okay, thank you all very much for your time. I think I'm out of time, and there's some slides that I didn't finish, but here you go. Thanks.